Hello, it's Alita from Science Stars here to do some fun hands-on science with you today. So today we're going to make a battery. A battery? How do you make a battery? Like this one? Or like this one? Not quite, but it will still work the same way and have the same amount of voltage or energy. Did you know that you can make a battery using a lemon? And did you know that you can light up an LED or a light emitting diode using a few lemons and some metal? So we're going to do that today. We're going to light one of those up by making a few little lemon batteries, connecting them all together and doing a bit of electrical science. To make the lemon battery, you're going to need 2 lemons, 5 alligator clips or crocodile clips. And they call it such because they have a little mouth that if you're not careful, ow, it can pinch you. So be very careful. Next, 4 copper coins, 4 galvanized zinc screws, and that just means that they're coated with zinc. A knife, we're going to use a plastic one to be safe, and an LED. Now, an LED is a light emitting diode, and these are the types of lights that you would see in fairy lights or the little lights that you hang around your Christmas tree. Have you ever looked closely at a battery? Look at this one here. Can you see 1.5 V? That stands for volts. And voltage is a way of measuring how much energy a battery has. Voltage is the force that makes electricity move through a wire. So let's test this battery. If it's 1.5 volts, my voltmeter should tell me 1.5 volts or thereabouts. So I'll attach one side to this end and the other one to this end, and I get 1.4. So 1.4 volts, so that must mean that some of the energy has been lost. Maybe it's already been used, or after time, batteries start to lose their strength. Now, can you imagine how different life would be if batteries did not exist? If it wasn't for this nifty way to store energy, we would not be able to have all the luxuries that we have today, mainly our electronic devices such as phones and tablets. And here we have a battery that would be used in a remote control for the TV. This would be used for, say, an Xbox controller. These you would see in your smoke detectors. This may be in your kitchen scale, and this one would be for larger things, such as if you have a remote control robot or something like that. We can credit this nifty way of storing electrical energy to a Mr. Alessandro Volta, who was a physicist, chemist, and pioneer of electricity, and is hailed as the inventor of the electric battery. That is where the name or the word volt comes from, after Volta. So, to make a battery, we need 2 different types of metals, which we'll call electrodes, and a liquid or paste, which we'll call an electrolyte. So, for a battery to work, the electrodes must be made of 2 different types of metals, and that ensures that they will react differently when they come into contact with an electrolyte. So that is what's going to generate the electricity. So when you connect the 2 electrodes with a material that will transport the electricity well, which we will call a conductor, then the chemical reactions can start, and the battery will generate electricity. It will convert the chemical energy into electrical energy. Sound confusing? Let's show you how it's done. So today I would like to make 4 batteries. So I'm going to cut my 2 lemons in half, because each half of a lemon is going to be the electrolyte that I need. So carefully using your plastic knife from your Science Stars kit, or if you don't have our kit, then ask for an adult to help you cut if you're using a knife from your kitchen. Let's see. So we'll put them onto 4 different plates to demonstrate the 4 different batteries. Okay, get a wee pattern going on here. Okay, so we have our electrolyte, and now we need our 2 electrodes. So the first one is going to be our copper coins. So very carefully with your knife, you can cut a little slit, maybe at one side of it, like so. It's actually the lemon juice that's the electrolyte. So we need to make sure that our coins are going to be able to come into contact with the lemon juice. So squeeze them in like so. Not too far in, because we're going to attach our crocodile clips to them. So they need to be able to grab on. Okay, so then we're going to get our galvanized zinc screws, and we're going to put them over on the other side. Now we don't want them to touch, but we do want them close enough together to ease in the transporting of the chemical energy or electrons. So electrons are going to be moving from the zinc to the copper. So now we're going to connect our batteries to each other, and we're going to see how much voltage we can generate. So we need to connect positive to negative, just like when you're putting batteries together, say in a torch, where you would put the positive, you can see the positive there, to the negative, which we don't have here, but we know that if this side's positive, this side's negative. Okay, so positive to negative, positive to negative. So zinc being negative, we're going to attach that to the positive copper over here. Okay, so this is like we're connecting batteries together in a line. So imagine 4 batteries in a line. That's what we're doing here. So then we grab the next one, which is on the negative zinc, and we're going to attach it to the positive copper. So then we're going to attach the negative zinc again to the positive copper. Okay, so do you see what's going on? So I've got 4 1.5 volt batteries here, just like the 4 lemon batteries we have. So I'm curious to see how much voltage I've been able to create with my 4 batteries. So I'm going to attach these alligator clips to the leads, the voltmeter leads, and see what we get. So have a look at the reading. 3.9. So nearly 4. Wow. So that's nearly 3 1.5 volt batteries, because 1.5 would be 3 volts, and another one would be 4.5. So we nearly have enough power to be the equivalent of 3 of these AA batteries. That's impressive. So we'll switch this off. We'll take these clips off of the voltmeter, and now we'll get our LED and we'll see if we can light this up. Now, when we go into classrooms and do this, the kids love it. They love seeing their LED light up. It's very exciting. I might have to turn the lights off though. So let's see. Now with an LED, one side is positive and one side's negative. So when you're looking at doing positive to negative, you want your negative from this end to be connected to the positive here, or else it's not going to work. It'd be like putting your battery in the wrong way. Okay, so we'll check and see. If it doesn't work, then we know we just have to swap the legs, right? So let me see here. Get that connected and see if this worked. Oh, I think I see something. That looks lit up to me. Oh my goodness. So I'm going to turn off my lights here, and I'm going to see if we can see it clearly. Now, bear with me. So, great. Hopefully you've been able to do this at home. If it didn't work, double check that you have the negative zinc screw connected to the positive copper in every occasion, okay? And just go around the circle, and then if that still doesn't work, check and see that you don't have the legs of the LED the wrong way around, okay? So I'm going to try it this way and show you that this will not work. Okay, so I'll swap it around again. So there you have it, your very own lemon battery times 4 batteries. So what do you think one battery's voltage would be? Will we check it out? As time goes on, the batteries will start to get weaker, just like a battery would wear out after you've been using it for a while. So here we have 1 volt. Okay, so that makes sense because they're nearly full 4 volts. So each one is roughly 1 volt each. Sometimes we get the question, can you get electrocuted because this is electricity? Well, I guess the answer is yes. However, it's such a low voltage that you wouldn't tend to notice it. Now, some of you might be more sensitive and you might feel a wee little tingle, but it wouldn't be a lot. I can't feel it, even though I'm trying to bring it together and see if I feel anything. So no, but in theory, yes, if it was a stronger battery, if there was more electrical current passing through, then yes, you would feel a shock and get electrocuted. So to recap, in order to make a battery, you need electrodes and an electrolyte. The copper coin and the zinc screw acted as electrodes, and the lemon juice in the lemon acted as the electrolyte. To power an LED or small bulb, we created more batteries and connected them together, creating higher voltage. For some fabulous resources on lemon batteries, visit twinkle.co.uk. I hope you enjoyed making a lemon battery today, and I look forward to seeing you soon. Bye for now.